Hello, my name is Monica Valcavi and I will be presenting on behalf of Team 12. Our project is called the Pet Sitter Bot. Before we begin, I'd like to start with a quick overview of what will be discussed in this presentation. We will discuss members of our team, project background, system implementation infrastructure, non-functional requirements, completed and future features, knowledge gained and the lessons learned, and a demonstration of the functionality of our project. We are Team 12, and our product name is the Pet Sitter Bot. Our team members include Angelica Isaac, the project owner, Monica Valcavi, the Scrum Master, Avatar Bola, a developer, and Santiago Alzate, a developer. When discussing the purpose and motivation for our project, we addressed a problem as well as a solution. A problem today is that many pet owners are not always available to be at home with their pets and to attend to their pets' daily needs. This can potentially lead to the animals being neglected throughout the day or potentially having to hire a pet sitter at expensive costs. We provide a solution for this issue. We created an innovative IoT device to provide pet owners with a reliable way of making sure their pets' needs are being taken care of while they are away. Our project has 4 main functionalities. We are able to monitor and control water levels. It acts as a food dispenser. We are able to view a pet in real time, and we're also able to talk to the pet. We have recognized one main potential target audience for our product. This audience is pet owners. This is due to the fact that there are 90 million dogs and 94 million cats in the United States alone. 68% of the United States households include at least one pet, making this audience a perfect opportunity for us to launch our product. Our system implementation infrastructure consists of 3 major components: the hardware, the software, and the languages used to make this possible. For hardware, we implemented a Raspberry Pi microcontroller, which acted as our primary microcontroller, a camera that allowed us to monitor the animal, a microphone and a speaker that allowed us to speak to the animal, and a smartphone or computer that would connect to the Raspberry Pi and allow us to view the pet and make adequate changes. For software, we use XAMPP to create a local server, Atom, a text editor used to create the web app, the Pet Sitter Bot web app, which was the app we created to connect to the Pet Sitter Bot, PHPMyAdmin, which was used for local storage of data, IBM Watson, used for chatbot functionalities, and Thonny was used for development on the Raspberry Pi. For languages, we implemented Python, used as a primary programming language for Raspberry Pi. This was used to create the scripts for the hardware. We used HTML, which is the primary programming language for the web development, and CSS and JavaScript as a secondary programming languages for the web development. We were able to identify 3 major non-functional requirements. We decided the device must be waterproof in order to prevent any accidents with the water. Water disbursement by the app would be limited if the water is determined to be at full level. And food disbursement by the app will also be limited if the food is determined to be at full level. Our product has 4 main completed features. We are able to monitor and control food made available to the pet. We are able to monitor and control water made available to the pet. We are able to view the pet in real time, and we are also able to speak to the pet. In the future, there are 2 features we would like to add. This would be adding alert notifications and pet sound detections. The notifications would be helpful in case water and food levels went below a desired threshold without the user knowing. The app would be able to alert the user of this occurring. The pet sound detection would be helpful in case the pet is now in a situation of distress. The creation and development of this product allowed for us to gain 2 important pieces of knowledge. 1, the use of agile practices, into the collaboration as a team, each with differing roles. In the demonstration video, both Santiago and Avatar will be demonstrating the functionality of our product.
Hello everyone, my name is Santiago Alzate. I'm from Team 12 and today I'm going to demonstrate our final project, the Pet Sitter Bot. But before I want to go over the hardware and software configuration. So let's start with the hardware. We have a Raspberry Pi Model B. And attached to the Raspberry Pi, we have a Pi camera and a voice hat that is made by Google. And attached to this hat, we have a microphone board. We also have a DC motor, which is the water pump. We also have a servo, which is the food dispenser. We also are using this ultrasonic sensor to calculate the water level. We have a speaker, and we also have batteries because the DC motor and the servo are draining a lot of current. Okay, so let's continue with the software. So we are connecting to the Raspberry Pi through BNC Connect. We are using the Flask and Python framework. And for each functionality, we made a Python file. And the starting point is this app.py file, which contains the Flask configuration. All right. Okay, so let's start the Flask web app server. So to do that, you have to open your console and go to your folder, and then you have to run the starting point, which is the app.py. Right. So we are using the port 80. And let's open from my laptop. So I need the IP address to be able to connect to the server. All right, so as you can see, we are able to stream the video. And also, we are calculating the distance to determine if the water bowl is empty or full. And we have the food dispenser and water dispenser. And also we are using the Watson services in here with the bot sitter helper, which is chatbot.
Alright, so this is our working prototype. So as you can see in this side, we have the food dispenser, and this side is the water dispenser. And here is the camera. This is the food holder, and we have the ultrasonic sensor right here. So we calculate if the water is empty or full with the ultrasonic sensor. So yeah, let's try. Right here we have the web app running. So let's first let's dispense the food. Right, as you see, the food was dispensed. Right. All right. Let's try it. The water dispenser. All right. As you can see, the water start dispensing. All right.
Good afternoon, everyone. I would like to introduce myself. My name is Avtar Bola, and for my portion of the project, I was mostly the software developer. So what I developed was this entire web page right here. I made sure the connections are working, make sure the buttons work with the Raspberry Pi, make sure the links work, and all that good stuff. And I also did like the styling and all that. So as you can see from this page, you can have your turn off or turn on functionalities. This will allow you to dispense food or dispense water whenever you've seen your pet like needs something or disappointed, or your pet is like hungry or thirsty and all that. The entire point is to monitor your pet to make sure he or she is doing fine. So I developed this in Zampa because Zampa is a very useful and well-rounded localhost application. It was very easy to develop. This was developed in Atom. Great for simple HTML, JavaScript type of for coding. So another I want to bring up a case scenario. So as you can see here, you should be like monitoring your pet and all that. And let's just say something went wrong, or you don't know what your pet's doing, and you want to know what's going on with your pet, or maybe she's hungry, maybe she needs food, or you don't know. So another feature we have in this project is the bot sitter helper. And as you click on here, it will take you to the IBM Watson Assistant, like the project we previously did for project 2. So I'm going to type in, let's say, my dog is hungry. And it responds with, right, how hungry is your dog, you know? and ask a question because you want to make sure. And I say, yes, the dog is hungry for food. And let's see what happens. And then so it shows you a menu of options that you could do. So let's click on dog. And it shows you all the different lists of foods that dogs usually eat, like chicken, pork, beef, and all that type of good stuff. So whenever you want to talk to need help with something, or you need to have a good idea what your pet needs, you could always go to this Watson assistant, and it will assist you or taking care of your pet. So let's go back. And here we go again. Like I said before, this was developed in a localhost. So some issues we did come up was I originally wanted this to be developed on an app. However, I own a Windows PC and I own an iPhone, so those two things don't really mix together. So a web page was much easier to do, and it's more open accessibility. So I have people in my group who could actually look at the page and look at the code to make sure everything's going right. Some things I would like to do in the future. Well, first of all, I would like to make this a lot prettier because it'll look good for the public. It does look user friendly, but it could just do better. The main issue we're having with like when we put up the URL for the camera, it kept on messing up the CSS. So we had to put functionalities in front of style. And later on, I hope that we could do more stuff instead of food dispenser and water dispensers. Maybe maybe in a Watson app, you could see contact veterinaries. It could become more over time as it gets more and more data. It'll be smarter and get more options for the user. So I hope this web page is user friendly, and hopefully also excuse me. Hopefully it's a user-friendly experience, and it's hopefully it takes care of your pet. I would also like to add that, and for my portion, a little bit, I kind of help with the construction of the actual dispenser. So that's my portion, and I'll leave it here. Thank you so much for listening.
This is an overview of the Trello board we utilized during the duration of our project. We split it up into do and doing, which are standard Trello features. We then decided that instead of using done, we would split it up into various components of the project. So we have hardware complete, software complete, integration tasks, and documentation complete. We felt that this was the best way to keep each of the tasks each team member had organized and provided the best way to maintain a checklist during the project. So for hardware complete, some of the tasks that we thought would be major milestones would be tasks such as collecting parts, design diagrams, and then getting each of the smaller sensors to work. For example, the ultrasonic sensor, the water pump, the servo, and then we also included the Python scripts that control the hardware into the hardware tasks, as well as the structure that the project sits in. For major software tasks, we thought a major milestone would be the starting of the development of the web app, the completion of the web app, and then the implementation of Watson within the project. We felt that major integration tasks were selecting a project idea that involved all 4 members of the team for high-level architecture, as well as integration of the hardware and software. We also felt that the demo was critical for all 4 members. For documentation complete, we split each piece of the documentation up into various components, and we kept track of those during the duration of the project as well.